This video is part 2 of a review of Unit 4 of AP Calculus. If you did not see part 1, go ahead and click the link that should be popping up in the upper right hand corner. In this video, we will talk about related rates, the derivatives of inverse trig functions, and L'Hopital's rule. For number 8 and 9, we have another related rates problem. In this diagram, points A and B are fixed at 8 meters apart. Angle B is always a right angle. The measure of angle theta increases at a rate of 2 radians per second, which causes point P to move upward along the dashed line. I don't see a dashed line, but it moves upward, which brings us to problem number 8. When y equals 6 meters, at what rate is point P moving upward? So this is a related rates problem. Let's start by writing down any rates or other facts that we are given. So we know that the angle theta increases at a rate of 2 radians per second. So let's write that down. d theta dt is positive 2 radians per second. At the moment in question, y equals 6 meters. So we've got that down. Now consider what we are trying to find. At what rate is point P moving upward? The rate of change of point P is going to be dy dt. So we are being asked to find dy dt. We need a relationship between these variables. The variables are theta and y. So looking at this picture, I'm thinking the tangent of theta is y over 8. That's opposite over adjacent. So that would be a relationship between y and theta. So let's write that down. So there it is. I put it right here in the corner. Again, tangent of theta is opposite over adjacent, y over 8. I'm going to rewrite this slightly to make it easier to see what I'm going to do next. This is tangent theta equals 1/8 times y. Let's go ahead and take the derivative of both sides with respect to t. So I'm doing d dt on both sides of the equation. This is because somehow I need to get d theta dt going, and I need to get dy dt in here. So the derivative of tangent is secant squared. But be careful, this will be the chain rule because these variables don't match. So the derivative of tangent is secant squared. However, I need to multiply now by the derivative of the inner function, which is d theta dt, chain rule. On the right-hand side, I see the constant, so I'm just going to bring the constant down and move on to dy dt. Remember, we are trying to find dy dt. So we need to have no other variables other than this. I know that d theta dt is 2, so that's fine. But this theta right here is a problem. We need to somehow find a value for this. At the moment in question, y equals 6 meters. So I'm going to go ahead and let y equal 6. Let's use the Pythagorean theorem to figure out what the hypotenuse is. So we've got h squared is equal to 6 squared plus 8 squared. So this is going to give us h squared is equal to 36 plus 64. H squared is equal to 100. and h is equal to 10. Or I could have used the Pythagorean triple 3, 4, 5, where 6 is 3 doubled, 8 is 4 doubled, so we knew that h would be 5 doubled. So that's another way you could get that h is 10. But why am I doing this? I said we needed to find a value for theta, but that's not exactly right. If I can have the value of secant theta, I'm good. So now that we have all three sides of this triangle, I should be able to find secant with no problem, because we know that secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse. So cosine theta is 8 over 10, adjacent over hypotenuse. This reduces down to 4 over 5. So that means that secant is going to be the reciprocal of this. Secant theta will be 5 over 4. So secant squared will be 5 over 4 squared. D theta dt is 2, and that equals 1/8 dy dt. 5 over 4 squared is 25 over 16, and that is being multiplied times 2, which equals 1/8 dy dt. Let's see, 2 goes into 16 8 times. So this is going to now become an 8. So I have 25 over 8 is equal to 1/8 dy dt. If I multiply both sides by 8, these 8s are going to cancel out. So I'm going to be left with 25 is equal to dy dt, and I'm just leaving space for the units, meters per second. So this is the final answer, and the answer is D. Number 9, when y equals 6 meters, at what rate is the area of triangle ABP changing? Let's start by listing everything we know. From the setup of the problem, we know that d theta dt is 2 radians per second. And from problem number 8, we know that when y equals 6 meters, dy dt turned out to be 25 meters per second. And now we are being asked to find dA dt. So we need a relationship that involves area. So of course, we will start by writing down the area of a triangle, which is 1/2 base times height. In this case, the base is a constant 8 meters, and the height is y. So this will be 1/2 8 times y. Half of 8 is 4, so that means that the area is 4y. Let's go ahead and take the derivative of both sides with respect to t. On the left-hand side, we have dA dt, which is what we are looking for. On the right side, we have this constant, so I'm just going to keep it, and I will move on to dy dt. But we know that dy dt is 25 meters per second. So that means that dA dt will be 4 times 25. So that is 100, and so we're talking about the change in area divided by the change in time. So area is in meters squared, and time is in seconds. So we have 100 meters squared per second. Number 10. A point P moves along the curve given by x squared plus y cubed equals 5, whose graph is provided here. Point P moves so that dx dt equals 4. When P is at 2, 1, what is the value of dy dt? We need to make this dy dt appear. So we can take the primary equation and differentiate term by term with respect to t. Because we are differentiating with respect to t, we will have to do the chain rule with the x term and the y term. So the derivative of the outer function will be 2x, but because we are differentiating with respect to t, we have to multiply by the derivative of the inner function, which is dx dt. Similarly, with the y term, the derivative of the outer function is 3y squared. But then the chain rule demands that we multiply by dy dt. The derivative of a constant is 0. They have given us an x and a y and the value of dx dt. So let's make those substitutions. So we will have 2 times 2, and then dx dt is 4, plus 3y squared, and y is 1, times dy dt equals 0. Remember, dy dt is what we are looking for. So 2 times 2 is 4, times 4 is 16. So we have 16 plus 3 dy dt is equal to 0. Subtracting 16 from both sides gives us 3 dy dt is equal to negative 16. Dividing both sides by 3, we have dy dt is equal to negative 16 over 3. So that's the final answer for number 10. Number 11. Consider the function g of x equals 2x squared times arctangent x. Find the slope of the line tangent to the graph of g at the point x equals 1. Are you telling me to find the slope of a curve at a point? That's derivative. So really they are just asking us to find g prime at 1. So let's do it. G prime of x. So I guess we have to use the product rule because we have this yellow factor and then the blue factor. So the first time through, I will take the derivative of the yellow portion, and that's going to be 4x. All right. And for now, this time through, we leave the blue portion alone. So arctangent x, and we put a plus. The second time through, we leave the yellow factor alone. So I have 2x squared. And I multiply by the derivative of the blue factor, and that is 1 over x squared plus 1. I'm going to go ahead and put the 2x squared in the numerator. So this is the derivative. Now we just need to find g prime at 1, the slope of the tangent at x equals 1. So here we go. G prime at 1 is equal to 4 times 1 times the arctangent, of 1 plus 2 times 1 squared over 1 squared plus 1. I'm going to go ahead and bring down this 4 for now. When you evaluate the arctangent of 1, you ask yourself the question, the tangent of what angle is equal to 1? And the tangent of pi over 4 is 1. That's a fact that we have memorized. So that's why the value of this is pi over 4. So I'm going to go ahead and put pi over 4 right here, all right, from the arctangent of 1. Plus, 1 squared is just 1. So I just have 2, And then here is 1 plus 1, so this will be 2. Okay, we could leave it like this at this point. This would be an acceptable answer, but we should practice in case we run into a multiple choice question or something. So g prime at 1 plus, it's so simple. Why not? Why not just do it, right? So you see that the 4 and the 4 will cancel each other out. So that's just pi. And then 2 divided by 2 is 1. So pi plus 1. So that's it. G prime at 1 is pi plus 1. This is the slope of the curve at x equals 1. Let's practice good habits. If this were a free response question on the AP exam, I would write my answer this way. The slope of g of x at x equals 1 is pi plus 1. Number 12. Find this limit using any appropriate method or state that the limit does not exist. The limit as x approaches pi over 2 of sine 2x times secant x. Well, remember this guy, this is a double angle. This should be signaling you that we will probably use a double angle identity. Please tell me that you have not forgotten these. Guys, these pop up from time to time, and there is no formula sheet on the AP exam. So take this seriously. If you need to pause the video for a minute, do what you need to do, but go ahead and memorize these formulas. Here's a few more. The one we need at this moment is right here at the top, though. Sine of 2a is equal to 2 sine a cosine a. So the sine of 2x will be 2 sine x cosine x. And then secant is 1 over cosine. So let's go ahead and do 1 over cosine. Notice that we have cosine in the numerator and cosine in the denominator. So these will cancel each other out. So now I just have this. But this is perfect for direct substitution. If we let x equal pi over 2, then we have 2 sine pi over 2. Pi over 2 is up there at the top of the unit circle where the y value is 1. So sine of pi over 2 is 1. So that means we have 2 times 1, which is 2. So that is the final answer. Let's call that method 1. Let me show you another way we could have solved this problem without using the double angle identity. Here comes method 2. The limit as x approaches pi over 2 of sine 2x times 1 over cosine x. So far, I just replaced secant with 1 over cosine. I'm going to go ahead and write these two as a single fraction. Let's see what happens if we try to do direct substitution. So in the numerator, we will have sine of 2 pi over 2. And in the denominator, we have cosine of pi over 2. Well, these twos will cancel out. So this is sine of pi, which is 0. And cosine of pi over 2 is also 0, indeterminate. However, since the numerator and denominator are both approaching 0, we can use L'Hopital's rule, which says that we can take the derivative of the numerator and the denominator without changing the value of the limit. In order to use L'Hopital's rule, make sure that you show this little step right here. Show that the numerator and denominator are both approaching 0 using two separate little arrows. This also works if they are both approaching infinity. Anyway, let's go ahead and take the derivative of the numerator and the denominator. The derivative of sine is cosine, so I'm going to have cosine 2x. Because this is not just an x, but I've got this function inside of a function, I have to do the chain rule and multiply by the derivative of the inner function. So I need to multiply by 2. I think I'll put the 2 in the front, though, to avoid ambiguity. So there's my 2. Now the derivative of cosine is negative sine x. So what happens if I try to do direct substitution now? So I will have 2 cosine of 2 times pi over 2. And then in the denominator, I have negative sine pi over 2. All right, but these 2's will cancel each other out. So I really just have cosine of pi. Cosine of pi is negative 1. So let me go ahead and show this. So I have 2 times negative 1. And then in the denominator, sine of pi over 2 is 1. So really, I have a negative 1 here, and this is also negative 1. So those cancel each other out, and I'm left with 2, which is the same answer I got the other way, but I'm using L'Hopital's rule instead of a double angle identity. So you can decide which works best for you.